Okay, just set a timer. And the next thing I want to do is we took all the time and effort to get this TX-TY formula. And it's the same thing. It's calculating the exact same thing. It's just that we happen to put the brackets in a different spot and change around what's being divided and what's being multiplied. And I want to see if, my hunch is correct and that these formulas are equivalent. Because everything I've done so far is telling me these formulas are equivalent. So I'm just going to make a note here. So var tx, var ty, and just make a note that that's tile x and tile y. The next thing I want to do is I also want to make a note that we could do this. Old formula is off by one error. Change is to has. So I'm going to make a little note here that the old formula has an off by one error, and this won't make a difference for anybody who's actually trying to transcribe this code, but in my syntax highlighting rules, I've made it so that I can kind of color code comments if I need to. So that's just going to help me see this blatant offense here. What is it that important to make it red, or should I just make it orange? Now I'm getting pedantic. Let's just make it orange, because if someone's looking at this code later and they're not, it doesn't require your attention to make sure nothing goes wrong. If it was some type of function that you had to call in a very specific way, that would be something that more so requires your attention in order not to make anything go wrong, and then I think I would make that red instead of orange. Okay, so let's comment back in the TX formula. And the next thing we want to do is make a note that SX equals TX and SY equals TY. Identical results. Okay, so now that we know that these formulas, we've made a little note that these formulas are identical, we're going to put in, we know that they also need to be floored with the way we've written the logic. We want to check to make sure that well, that doesn't look good. Extra bracket. Okay, let's go over here where we have the TX formula. Okay, I'm gonna... Oh, you know what? Did I remove the bracket next to the floor when I did that? TX. Got, yeah, then we're plussing SX. Oh, okay, so I see kind of like, yeah, it looks like I forgot. So I'm gonna just take TX and TY again, and I'm gonna paste it again rather than I want to make absolutely sure, and I'll get rid of this because I keep on flipping there. So I'm just gonna paste the TX TY here again, and because it looks like when I was moving this around, I deleted that parenthesis because that's no longer balanced. Okay, so now that we have that, and we'll change these brackets back to parentheses. Sometimes, I don't know, for whatever reason, I don't know what my deal with English is, because it's my native language, but parenthesis makes no sense to me. Like, that word, I don't understand that word. Like, parenthesis and comma, like, I get them mixed up in my head all the time. So sometimes, I like to call this symbol here, I like to call it a bubble bracket, right? Bubble brackets, square brackets, and angled brackets. Just because parenthesis, I don't know, it just doesn't make sense. Like, parenthesis kind of, to me, sounds like ellipsis. So when I say parenthesis, like, I don't think that shape. I think this for some reason. I think dot, dot, dot. I don't know why. So bubble bracket for whatever reason, right? Because it has that curve to it. It can look like a bubble. I tend to like to call it a bubble bracket. But then people wouldn't know what the hell I'm talking about. But maybe I should just do it anyways. So these formulas, when I transcribe the tx and ty, right, I'm flooring it here. But before I was flooring this section before adding on the sx and sy. It should have the same results though, right? Because these are expected to be whole numbers. So the next part is, let's just make sure this still runs. That we didn't like make any egregious error in the syntax. So we did not, so that's good. And the next thing I want to do is I just want to say that we're just going to do a little assert to make sure that sx and tx are correct, and then if they're not, we're going to inspect the values and see, well, how different are they? Because there's the potential of, well, they should be whole numbers, so they should be identical. We shouldn't even have to decide if they're like significantly close, because the formula is dealing with whole numbers, so they should be dead on exact. So if sx is not equal to sy, or not, sorry, tx, so if source x is not equal to tx, then we done fucked up. So throw, and we'll just put sx not equal to, and then tx. And then we'll copy this, and we'll use the same statement for the tile x and tile y. So I guess if you didn't notice, I like redundancy. So, sorry, source y and then tile y. I'm a fan of redundancy because I screw so much stuff up that it's nice to have redundancy to give me some sanity of thought. Okay, so if all my assumptions about these two formulas are correct, then when we run this, we won't have any errors, because these values will, no matter what we do, for every single pixel of the canvas that it's iterating over, this assertion will always, so basically I'm trying to assert that these two are equal. So I wanted to say this assertion will always be true, but because of the way I've written it, that's not quite grammatically correct, but hopefully you get the idea of the assertion that I'm trying to prove true, right? Let's just go over here, let's refresh and see what happens in a moment of truth here. Nice. So I don't see any errors being thrown, and we might want to do a quick sanity check. So let's in one of these assertions, let's put a tx plus 1, right? And the reason for that is I want to make sure that this code is actually executing, because sometimes I get paranoid when it works and it doesn't break on me. I'm like, what the hell? I just wrote all this stuff and you're telling me I didn't do anything wrong? That seems wrong. Okay, so let's refresh, and now I'm going to expect for that code to throw an error. So let's, okay, yeah, so now we got an uncaught exception, and it says sx is not equal to tx. And it's kind of fucked up our canvas here as well. So we can remove the, we're going to remove that from the code now. And now we will go back over here, and we're going to refresh. And now it's back to normal. We don't get that error. We're going to zoom in, zoom out. That still works. We're going to press our arrow keys to move around. Excellent. So after a lot of thinking, I've basically just rewritten the old tile formula, and by rewriting it, I've realized that the old formula was off by 1, and we fixed off by 1 error in the code. So right here. So here's the original formula, but it's corrected with our +1s, and here's the new formula that we've been working on, which is pretty much exactly the same, except for how some of the terms are grouped. But with that, we need to get back to solving the original problem on hand. So I'm going to delete some of this crap over here. And here's the viewport problem we're trying to solve. And we have some stuff for, do we have a local x and a local y yet? So we have, right here, I have a comment, convert dx dy to local chords. So we're taking dx and we're subtracting the origin of the dx rectangle, which is giving us a local dx dy coordinate. And tile x, so this tile x formula here is, it's the same formula as these guys here, but we use substitution to derive that. And we don't really want to, we would prefer to use this formula here, just because some of these terms that we've created are going to make it easier to comprehend. I don't know. It might be an opinionated aspect there. Okay, so once we have the local coordinate, all we got to do is like divide by the size of a tile as it appears on the source, and then we'll have what tile we're in, and then we can do some truncation to get local coordinates within the tile. And we already know what tile we're in, right? Yeah? Yeah, we know what tile we're in, but what is the size of a single tile? And I know we had number of sections, and number of sections. And what are we doing with number of sections? Are we doing anything with the number of sections yet? Size of tile. Okay, so the size of the tile in the destination viewport. Okay. So with that, yeah, that's there. Size of a tile. Hold on. So we know the size of a tile. So we have something like, so now that we know the size of a tile, and we know what tile we're on, we can say something like, I'm not sure what to call this variable, but it's like var used up pixels x equals the tile x times the width of a tile, right? So, and then we have used pixels y, and that's going to be the tile y value times the height of a single tile, right? So if we are at tile 0, 0, we multiply by the width and the height of a single tile, and we find out that our used pixels x and y is 0, which means that we don't have to do any trickery to figure out the local coordinates of dx and dy, because it's I don't know how to explain this. Let's just solve it, and maybe somebody will come up with a better term for this. So the var, so we have So tile, local tile chord, tile internal. So we have some type of internal, we have like a local tile coordinate, but the, that seems kind of ambiguous because, that could be the local position of a tile on a tile map. I want like the internal pixel coordinate within the tile. So it could be like a tile internal coordinate and then X and Y or something, or it could be tile internal X and then tile internal Y, like that. We could do that. Let's see how we've written some of these other variables. Or it could be internal tile coordinate, ITC, and then we could do like X like that. Tile internal, but tick, I don't know if that's pronounceable, so I do kind of like that. So tile internal coordinate for like the local pixel within that tile, basically. Or tile TLP for tile local pixel. We could do that. But the idea is we want to have some type of variable that stands for the local pixel coordinate within the tile, right? So if all of the tiles are 64 by 64, that means their local coordinate system for those tile local pixels is 0 to 63 inclusive. We've been getting pretty shorthand with stuff like this. Local chords, we're going to run out of that if we keep doing that, aren't we? Tile internal coordinate. Internal coordinate is a little bit more generalized than pixel. So tile internal pixel, but now that looks like tip, which that could be confusing. Well, I mean, what else are we going to use for internal coordinate on a tile? I mean, we could eventually be using like float values instead of pixel values, like especially if we move this into OpenGL and we're using a fragment shader, then usually you think about the coordinates as pixels, but really they're fragments, so maybe we just want to say tick for coordinate. So tile internal coordinate and then X like that. That does bother me because it doesn't quite line up. Or we could just, you know, do that, but then that's kind of weird as well. Or maybe we could use it more space. So I'm just trying to figure out like how can I get these variables to like line up nicely. So tile internal, could do that. Tile and so tile internal coordinate X and then Y, right? So now we've made kind of a pronounceable thing, but the idea is that I just want this variable to also be able to line up with like a variable in this format. Yes, very OCD kind of things I do. But yeah, I kind of like that. So what we'll do is we can make a little note here that this is tile internal coordinate, and then that's X, right? Tile internal coordinate X, and tile internal coordinate Y. So get local pixel coordinate value from within the current tile in focus. Is my timer running? Yeah, I got 15 more seconds. And I do want to make a note of this variable, like if that's, you know, what I'm going to use. Let me stop the timer. I'm going to start another video.